If subnetting has ever felt confusing, don't worry, you're not alone. The problem usually isn't the math, it's that the structure of an IPv4 address was never fully explained. In this lesson, we're going to start at the very beginning and look at how IPv4 addresses actually define a network. Stay with me until the end of this video, because once you see how IPv4 addresses are structured, subnetting will start to make a lot more sense for you. By the end of this lesson, you'll be able to look at a network and immediately recognize the network address, the broadcast, and the usable IP addresses within a subnet that can actually be assigned to devices. Before we learn subnetting, we need to understand what an IPv4 address actually represents. An IPv4 address is written in dotted decimal format. Don't let that term intimidate you. It just means that there are dots here and there are decimal numbers here. An IPv4 address always follows this basic structure of 4 decimal places separated by 3 dots. Every IPv4 address contains a network portion. This identifies all of the IP addresses within a group. And it also contains a host portion. These are the unique identifiers that you can assign to each device within that group. Here we have our network example, 192.168.10.0. This indicates the network ID. Devices in this network will all share the 192.168.10 portion of this address. The last section, starting at .1 in this example, .1, .2, .3, this would identify the individual devices within each network. So why split IPv4 addresses into network portions and host portions? Or I should say, why are they split like that? Because devices must know which network they belong to. And therefore, they know which devices are also part of the same network that they are in. Devices can communicate directly with other devices that are on the same network, but for different network devices, that requires additional networking equipment. For example, if we have our 192.168.10.0 network, and then a couple of devices on that network, or a few in this case, we have a PC, a laptop, and a printer. The devices on that network can communicate with each other without any special networking equipment. But if we have devices on another network, maybe a 192.168.20.0 like we have in this example, then the .20 makes this a different network. The devices within the 192.168.20.0 network can communicate with each other. But these devices that are on different networks cannot communicate with each other unless we add a special device, which is a router. Now that you understand that an IPv4 address contains a network portion and a host portion, there are also 2 special IPv4 addresses that exist in every network. Every network needs a name, and so the network ID is the name of the network, and that identifies the network. This network ID cannot be assigned to any individual devices on the network. In every IPv4 network, we also have a broadcast address. Broadcast addresses are used to send messages to every device on the network at the same time. This address, the broadcast address, can also not be assigned to any individual device on the network. The good news is that to make our life easy, it's always the first IP address in any individual network that is the network ID, and to keep things simple, it is the very last IPv4 address that is the broadcast address. You may be wondering then, well, what addresses can we assign to devices on a network? That's a simple answer. Everything in between the first and the last IP address on a network can be used to assign to an individual device. These addresses are called the usable IP addresses. Remember at the beginning of this video when I mentioned that you're going to be able to recognize which addresses can actually be assigned to devices? Well, now you know. The first address identifies the network. It's the network ID. The last address is the broadcast address. You can't use those to assign to devices, but everything in between is a usable IP address. Well, if IPv4 addressing were as simple as our last example, everyone would know how to do this in just a few minutes. But take a look here. If I show you this IP address, can you identify the network portion and the host portion? What would the broadcast be? What would the network ID be? Right now, there's no way to tell just by looking at the IPv4 address all on its own. Computers need one more piece of information. To understand how computers determine the network and host portions, we have to have a subnet mask. In the next lesson, which should be linked up here, we'll see how computers actually use a subnet mask to determine the network portion and the host portion of an IPv4 address. Thanks for watching this video. I hope you learned a lot. You look like you actually did learn a lot, and that makes me really happy. I hope to see you in the next video. Bye-bye.